So this is a lesson on section 7.3, which has to do with similar triangles that are formed when we draw an altitude in a right triangle. So the first theorem that we have is theorem 7.5, and it tells us that if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So we will be using what we learned in chapter 6 in this new lesson. So the first thing I'm going to do is I'm going to illustrate this theorem by drawing a right triangle. And I'm doing my best here, but imagine this is a perfect right triangle. And I'm going to call it ABC. So I have a right triangle, and I'm going to draw an altitude to the hypotenuse. So the altitude means that it's a segment that is perpendicular to the hypotenuse, and it also has to go through the opposite vertex. So it's going to look something like this, and it's going to be perpendicular to the hypotenuse. I'm going to call this point D. And what I have is I have two little triangles and one large triangle. And they are all going to be similar because we're going to take a look at what we have here. So we have this angle B, and I also have this angle C here. Oops. All right, we're going to redraw with the red one. Okay. So for each triangle, you are going to have a red angle, a right angle, and a blue angle. So what I mean is this. I'm going to redraw angle ADC here. So ADC. And this was, so I'm going to pick, this was my red angle. So if I look at the very large triangle, the red and the blue angles have to be complementary because we have 180 degrees in a triangle and we already have a 90 degree. So the red and the blue angle have to be complementary. If you look at triangle ADC on the right, the angle A and the red angle also have to be complementary, which means that the remaining angle also has to be congruent to the other blue angle. So basically, every triangle that you have will have a blue angle, red angle, and a red angle. And the same thing is going to happen to our other little triangle, which I'm going to draw here. And our other triangle is BDA. And if we look, we already had our angle B colored in. And again, if my triangle has a right angle, a blue angle, the remaining missing angle would have to be a red angle here. And I'm using colors because the numbers could be anything. So basically, by angle similarity postulate, all three triangles have to be similar to each other. So this is what that theorem tells you, that all three, the big triangle and the two little triangles that we have, so one little triangle is this one, and here's my other little triangle. So they all have to be similar to each other. So we're going to take a look at example 1, and we're going to use the similarity and what we know from chapter 6 in order to solve for x. The first thing they asked me is to identify the similar triangles. So we know there are going to be 3 similar triangles, and I'm going to take my colors and I'm going to color in my angles, and I'm going to refer to them by colors. And that's going to help us when we write the similarity statement. So the first thing I'm going to do is I'm going to say triangle EHG is similar to another triangle, and it's going to be similar to another triangle. And then what I'm going to do is I'm just going to mark some things. So angle E in the big triangle is going to be my red angle, so I'm going to put a red dot here. Angle G is going to be my blue angle. Angle G is going to be my blue angle here. So I'm going to make sure it's blue. And angle H is going to be my right angle here. So when I write my similarity statement, I always want to make sure I go in the same order. So I'm going to go red angle, blue angle. So then I'm going to do my two little triangles. First, I'm going to do triangle EFH. So in the triangle EFH, I'm going to have my right angle in the middle, which is angle F. And I have colored in the red one, so E has to be here. And then the other angle that I have left, which is H, has to be the blue one. And then in the other little triangle, which is the one on the right side, which is triangle FGH, I am going to put my right angle in the middle. I'm going to put my blue angle at the end because I already have it colored in. So my remaining angle, which is going to be angle H, has to be the red one. So this would be my similarity statement. And I have all my corresponding angles in the right places. Then I'm going to find the value of x. What I'm going to do here is I'm going to set up proportions, and I'm going to think about each side as a hypotenuse, long leg, or a short leg. So these are my three choices, and that is how I'm going to set up my proportion. I look at my large triangle, and I notice that I have my long leg, which is 15 here, my short leg, which is 8, and I also have my hypotenuse, which is 17. And I just need another triangle where x is one of the sides. So I'm going to use this little triangle here. And in that little triangle, x is going to be my long leg and h is going to be my hypotenuse. So if I have long leg and the hypotenuse that I want to use, that's how I'm going to use I'm going to set up my proportion. So I'm going to do long leg over the hypotenuse. Okay, so in my little triangle, my long leg is x and my hypotenuse is 8. In the very large triangle, which is the 15, 8, 17 triangle, my long leg is the 15, and then my hypotenuse is 17. So this is how I set up my proportion. You just want to make sure that x is in your proportion so we can actually solve for it. Once you have this, then you just cross multiply, and we get that 17x is going to be equal to 120. And then all we have to do is divide both sides by 17 to get our final answer. And our final answer is going to be x is equal to 120 over 17. So that is going to be my answer to the first example. So I'm going to pause the video, and I'm going to ask you to try this problem on your own, and then when you play the video, you should see the answer. So hit a pause and try to see if you could do this question on your own. Alright, so I'm going to write the answer to this question, and the triangles that we have here should be ABC, similar to triangle ADB, similar to triangle BDC. So that is the similarity statement where we identify the triangles, and then the value of x should be 336 divided by 25. So that is the answer to the first exercise. Here's our second problem of the exercises, and once again, try to hit the pause and try the problem on your own, and then see if you got the right answer. Alright, so I'm going to write the answer, and my similarity statement is going to be triangle EFG is similar to triangle EHF, similar to triangle FHG. Okay, and the answer to x is equal to 180 over 17. And notice that I'm not going to give my answer as a decimal. I keep it as a fraction, but I make sure it's simplified. Alright, so now that we tried both of these, we're going to move on to our second example. And again, what I'm going to do is I'm going to think of this as a combination of three sides, short leg, long leg, and the hypotenuse. And I just want to make sure I have a proportion where y is in the proportion. So first I'm going to take a look at this little triangle here. And I notice I have y. Y is my hypotenuse. And I also have 8. And 8 is a short leg. So that's going to be my proportion. So I'm going to do hypotenuse over short leg for both triangles. So for my little triangle, my hypotenuse is y, and my short leg is 8. And I don't have a lot of choices, so then I have to use the large triangle because I don't have a lot of labels here. So in my large triangle, this is my hypotenuse, it's 26, so I'm going to put it on the top because that's where we're going to put the hypotenuse. And then y is my short leg, so y. And then I have an equation with only one variable, so we could definitely solve it. I'm going to cross multiply, and I get that y is equal to, or y squared actually is equal to 208. And don't forget that y times y is y squared, because some of us forgot that on our last test. So then we're going to take a square root of both sides and get an answer of square root of 208. However, we have to make sure we write our answer in simplest radical form. So we have to take a look at the factor tree for 208. So it's an even number, so I'm going to start with a 2. So it's 1 and 104. 104 is still even, so 2 and 52. 52 is still even, so 2 and 26. And 2 and 13. Okay, so I'm running a little bit out of room here, but I'll try my best to write legibly. Okay, so I'm looking for pairs of numbers. I have a pair of these 2's, and I also have a pair of 2's right here. So I had a 2 on the outside and another 2 because I had 2 pairs. 13 did not have a pair, so I'm going to leave it inside. And my final answer will be 4 square root of 13. So 4 root 13 is my answer for y. Alright, so we're going to try a couple problems on our own. So try to pause the video and try this number 3 on your own to see if you got the right answer. Alright, so the right answer is going to be 4 square root of 5. And I'm going to go over this really quickly. So if I look at my little triangle that has x, I have the hypotenuse and short leg. So if you look at this triangle, here's your hypotenuse and here is your short leg. So I'm going to use that. My proportion is going to be hypotenuse to short leg. So I'm going to say x over 5 is the same as, now I'm going to take a look at my big triangle, where this is my hypotenuse, 16, and my short leg is x right here. So then once you have that, you're almost done. You cross multiply, and we get x squared equal to 80. And then I take a square root of both sides, and I get x is square root of 80. And it is not in simplified radical form, but that's what we have to do. So we're going to do the factor tree. So I'm going to do it on the left side. I'm just going to use a different marker so it doesn't get jumbled up. So 80. So 8 and 10. And then 8 is going to be 2 and 4. And 4 is going to be 2 and 2. And 10 is going to be 2 and 5. So then I'm going to go back and look for pairs. I have a pair of 2's here. I also have a pair of 2's that are kind of far away from each other, but I still have them. So that means that I have 2 times 2 on the outside, which is 4, and I have 1 5 that did not have a pair, so that's going to stay inside. So 4 root 5 should be your answer. And then we have one more example to try on our own, which is number 4. So I'm going to pause it so you could try it, and then we're going to see what the answer is. Alright, so for number 4, if I look at the really large triangle, actually let me write the answer first. The answer is going to be 5 root 6, and I just want to go over how I got that. So for the large triangle, the only side I actually know is the hypotenuse, and I don't know anything else, so it's actually not a good choice to use. So what I'm going to do instead is I'm going to take a look at this triangle here, and I have a long leg and a short leg. And then I'm going to look at this triangle right here, and it looks like I have short leg and a long leg. So my proportion is going to be long leg to short leg, and it's going to be 15 over x is equal to x over 10. And I got x squared to be 150. Which means that x is square root of 150. It is not in the simplest radical form, so I'm just going to break it up. 15 and 10, 2 and 5, 3 and 5, and then I'm going to look for pairs. It looks like the only pair I have is a pair of 5's, so that is why I have a 5 on the outside, and then 3 and the 2 got multiplied together and stayed on the inside. So that is my answer for number 4, and that's it for our lesson.